Okay, good morning, mathematicians. Today we're going to cover section 5.3 in our quadratic function notes, and this is modeling with quadratic functions. So what we're doing is we're just looking to see if these coordinates are actually on the parabola. So you'll see here that I've got three sets of coordinate points, and I have a function, and remember, we typically write our notation as y equals f of x, meaning that y is some function of x. So what we're going to do is we're just going to verify that these coordinates are actually on this parabola. So it's more like a true or false or a verification type deal. So let's take a look at problem 1. And in problem 1, remember, I read coordinates x, comma, y. So this is my input, and then this should be my output when we are working with these functions. So here, f of 0 in theory should equal 0. If x is the input value, 0 should be the output value. So I'm going to go here and I'm going to do 2 times 0 squared plus 4 times 0. Well, 0 squared is 0. 4 times 0 is 0. It looks like f of 0 equals 0. So 0, 0 would be a coordinate that is on this parabola. So this is true. So that's the idea here. So let's take a look at another example. Okay, now I'm going to try f of -1. And if -1 is on this parabola, then the output should be -2. So I'm going to sub in anywhere that I see an x. I'm going to replace it with a -1. And remember, I keep it in parentheses so that I can keep my signs organized. So here, -1 squared, -1 times -1 is a positive 1. And then positive 4 times -1 gives me a -4. Okay, so we go to the next line here. 2 times 1 is 2. 2 minus 4, well, it looks like when x is -1, the value of the function is -2. And so that's going to give us another correct point here. Okay, so now we got to verify the last one. So let's check f, not of 3, but f of 1 now. So if f of 1 is on there, 6 should be the output. So anywhere I see an x, I'm going to sub in with a 1. Okay, so I've got f of 1 equals, well, 1 squared. 1 times 1 is 1. 4 times positive 1 is going to give me 4. So I have f of 1 equals 2 times 1 is 2. 2 plus 4 gives me 6. So when x is 1, y is 6. The output of this function is 6. So it looks like all three of these points are actually on this parabola for us. So that's all we're doing today. You're going to have a Delta Math assignment on this, and you'll just have to determine if the point is on the parabola or not, and we will do this by direct substitution. So that's an example there. We've got two more, and they look a little spicy because now, look, these are all in standard form. So what I'm going to do now is I'm going to set you up, but then I want you to pause the video and try it for yourself. So let's look here at problem 2. I want f of 1. So anywhere I see an x, I'm going to replace it with a 1. So I will do that for you. Okay, that's going to be your first coordinate check. Then we need to check f of -2. And remember, anywhere I see an x, I'm replacing with a -2. But on top of that, I'm also keeping it in a parentheses because I want to keep the signs consistent. And then last one here, f of 3. So anywhere I see an x, we'll replace it with a 3. All right, so go ahead and pause the video, try it out for yourself, and then we'll come back together so that you can attempt to verify your work. So go ahead and pause the video now and give yourself like maybe 3 minutes to try this out. Well, I got a little sloppy with my work here towards the end, but as you can see here, 2 times 1 is 2, 2 plus 3 plus 5 is 10, and so forth. So literally all we are doing is just directly substituting the x coordinate into the y coordinate here. So that's pretty much the lesson for today. What I need from you all now is let's make sure we've got this down. So let's take a look at this again. We're going to plug in -2. Anywhere we see the x. So again, 3 times -2 squared minus 2 times -2 plus 1. Okay, well, -2 squared, -2 times -2 is a positive. Here, -2 times -2 is a positive, and then we've got plus 1. So 12 plus 4 plus 1, 16 plus 1 does give me 17. So the point negative 2, 17 is on this parabola. Okay, let's check 1. So f of 1, we have 3 times 1 squared minus 2 times 1 plus 1. Let's check it out. Well, 1 squared, you guessed it, is 1. Negative 2 times positive 1 is negative 2 plus 1. So I have 3 minus 2 plus 1, and I'm just using PEMDAS here. So nothing fancy. I know it feels like I'm going fast, but it's okay. So now we go left to right. 3 minus 2 is 1, and 1 plus 1 is 2. So guess what? The coordinate 1, 2 is on the line. Now let's check f of 2. Again, we're going to do 3 times 2 squared minus 2 times 2 plus 1. Well, 2 squared is 4. Negative 2 times 2 is, negative 2 times 2 is 4. Negative 4, sorry, plus 1. So we have 12 minus 4 plus 1. 8 plus 1 definitely gives me 9. So all 3 of these coordinates are on the parabola. Okay, so you have enough of what you need to do. Today's lesson is more focused on computation, and just the main takeaway is that if the point is on the parabola, then mathematically the x input value will produce the y output value. So that's all there is for today. What I need you all to do now is to log into Delta Math and complete your section 5.3 assignment and use your notes to do so. Email me if you have any questions or your respective Algebra 2 teacher. But best of luck, Chargers.